Good morning, grade 6s, and welcome to WorksheetCloud, grade 6 Natural Sciences. If you have a question during this lesson, send an email with your question to grade6@worksheetcloud.com. As you know, my name is Mrs. Hall, and I look forward to teaching you this lesson on the solar system. Today, we are going to be looking at the outer planets. So sit back and enjoy. So let's start with what are the outer planets. These are the 4 planets furthest from the sun and are known as the outer planets. And they are Jupiter, Saturn, Uranus, and Neptune. In our solar system, astronomers often divide the planets into 2 groups, the inner planets and the outer planets. The inner planets, as you know, are closer to the sun and are smaller and rockier. The outer planets are further away, larger, and made up mostly of gas. The 4 inner planets have slower orbits, slower spin, no rings, and they are made up of rock and metal. They are called the terrestrial planets for those of you who listened to my previous lesson. The 4 outer planets have faster orbits and spins and a composition of gases and liquids. They have numerous moons and rings, and they are called the Jovian planets, the outer planets, and they are named after Jupiter, the largest planet in the solar system. They are also called the gas planets because they consist mainly of hydrogen, giant planets, because of their So, why are the Jovian planets further from the sun? They are formed further from the sun where ices and rocks were plentiful. The cores accreted rapidly into large clumps of ice and rock. Eventually, they got so large they captured a large amount of hydrogen and other gases from the surrounding nebula with their enormous gravity. So let's get started with Jupiter. So Jupiter is the 5th planet from the sun, and it is a gas giant. A gas giant is a very large planet made mostly of gases. Jupiter is the largest planet in our solar system. In fact, if it were hollow, it is so big that all of the other planets could fit inside of it. Isn't that just amazing? Jupiter has many moons. Galileo was the first person to see the 4 largest moons through his telescope in 1610. They are about the size of Earth's moon. One example is Europa, and this is the smoothest object in the solar system. The upper layer of Jupiter's atmosphere contains clouds of ammonia in bands of different colors. These bands rotate around the planet, but also swirl around in turbulent storms. The Great Red Spot is an enormous oval-shaped storm found south of Jupiter's equator. This storm is more than 3 times as wide as the entire Earth. Clouds in the storm rotate in a counterclockwise direction, making one complete turn every 6 days or so. The Great Red Spot has been on Jupiter for at least 300 years, since astronomers could first see the storm through telescopes. There you have it. Jupiter's atmosphere has a weather system called the Great Red Spot that has been raging for centuries. It is a disturbance more than 3 times the size of Earth. Here I have another picture. This image of Jupiter's Great Red Spot, upper right of image, was taken by the Voyager 1 spacecraft. The white storm just below the Great Red Spot is almost the same diameter as Earth. Now let's take a closer look at Saturn. So Saturn is the sixth planet from the Sun, and Saturn is also a gas giant. Like Jupiter, Saturn's atmosphere is mostly hydrogen and helium. The Voyager space probe explored Saturn's rings. It showed that the particles that make up the rings range in size from tiny little grains to huge big boulders. Saturn is famous for its beautiful rings. Although all the gas giants have rings, only Saturn's can be easily seen from Earth. Saturn's mass is about 95 times the mass of Earth, and its volume is 755 times Earth's volume, making it the second largest planet in the solar system. Saturn is also the least dense planet in the solar system. It is less dense than water, and Saturn orbits the Sun once about every 30 Earth years. Here we have an image of Saturn and its rings in a composite of pictures taken by the, I need to put my glasses on, the Cassini orbiter in 2008. Over here we have Saturn's moons. Saturn has many moons. Like Jupiter's moons, most of Saturn's moons are small. Its largest moon, Titan, may be the most unusual moon in the solar system. It has an atmosphere, and Titan is larger than Mercury. So here we have a composite image again comparing Saturn's largest moon, Titan, on the right, to Earth on the left. Let's take a look at our fact sheets. So just take a look over here. We've got Jupiter facts, Saturn facts, and we're not going to read through all the different facts, but I have got a few questions to make you study them in a little bit more detail. And for those of you who are passionate about the planets, feel free to pause me and take some notes. So my first question is, using chart, what is one reason people cannot live on Jupiter and Saturn? So take a look at Jupiter and take a look at Saturn. And straight away, what shouts out to you? I would take a look at the temperature. Over there in Jupiter, -148 degrees Celsius, and Saturn is -178 degrees Celsius. So they are way too cold to live on. Using the chart, what planet has more moons? So we go to moons over here, and you can see the numbers. Which one has the most moons? Correct, Jupiter with 63. Now, this planet, Uranus, and I especially put in the spelling and the correct pronunciation, Uranus, because this poor planet is the butt of many jokes, especially in the science class. But you know what? You need to laugh, grade sixes. So, yeah, some people call it Uranus. And we make lots of jokes about it in the science class, but the correct pronunciation is Uranus. And it's named for the Greek god of the sky. So Uranus, in 1781, William Herschel discovered a seventh planet orbiting the Sun. The gas giant Uranus is the furthest planet you can see without a telescope. Uranus is so cold and is a liquid. Tiny drops of liquid methane form a thin cloud that covers the planet. This gives Uranus its fuzzy blue-green look. As you know, or some of you might not know, Uranus rotates on its side. No one knows why Uranus has this tilt. Scientists think that an object may have collided with the planet when the solar system was still forming, and this bump may have knocked Uranus on its side. Let's take a look at Neptune. So Neptune is the 8th planet from the Sun, and it is the smallest of the gas giants. Even so, if Neptune were hollow, it could still hold about 60 Earths. So how small is it really? It is so far away that it cannot be seen without a telescope. And in 1846, astronomers discovered Neptune. A few days later, they spotted Triton, Neptune's largest moon. And here are our facts on Uranus and Neptune. So let's move over here and you can study these fact sheets and let's get some questions up. My first one is, which planet has a larger diameter? So go to the fact sheet, look for the word diameter, okay? Look at the differences and tell me which one has the larger diameter. Correct, Uranus. How much longer is the Earth day on Uranus? So go to the Earth's length of day as measured in Earth time, 17 hours, remembering it spins backwards, and Neptune is 16 hours. So how much longer is the Earth day on Uranus? Bit of a trick question here because you want to say 17 hours, but the question was how much longer is the Earth day? And it's 1 hour longer. Okay. So we have our 4 outer planets: Jupiter, Saturn, Uranus, and Neptune. As you know, Galileo Galilei lived from 1564 to 1642. He was a mathematician and an astronomer. He agreed with Copernicus that all planets revolve around the sun, and he used a telescope to observe the sun, moon, planets, and stars. And we will be looking at that in our next lesson. So as Galileo said, when I sat in through my telescope, I was surprised. I saw what looked like a planet with handles. The handles were actually the brilliant ring systems that orbit the planet. So we ask ourselves the question, what's the matter with Pluto? Oh, sorry, I need to go back there. So until 2006, Pluto was considered a 9th planet. Did you know this? But Pluto is different from the 8 planets in several ways. Now scientists refer to Pluto as a dwarf planet. A dwarf planet is a small ball-shaped object that revolves around the sun. Shame, poor Pluto. Imagine being kicked out of the planets. Right, let's take a look at how well you listened, grade 6s, and let's see if you can get all the answers to this quiz. So, let's take a look over here. The furthest planet you can see without a telescope. Would it be Jupiter? Would it be Uranus? Would it be Neptune? What is your choice? What are you going to go with? I'm going to go with Uranus. Let's see if I'm correct. Yes, I was. The largest planet in our solar system. Is it Jupiter? Is it Saturn? Is it Neptune? Who are you going to go with? I'm going to go with Jupiter. Good. Well done to those who got it. The smallest planet of all the gas giants, and remember, it's not really even that small. Is it Jupiter? Is it Saturn or is it Neptune? Who would you go with? I'm going to go with Neptune. This planet has a weather system called the Great Red Spot. Okay, is it Jupiter, Saturn, or Neptune? I'm going to go with Jupiter. This planet rotates on its side. Easy one. Jupiter, Saturn, or Uranus? What's going to be, grade 6s? I think I'm going to go with Uranus. Well done. You passed. Right, grade 6s, I have a little recap video for you. I hope you enjoy it and it consolidates everything and helps you to make sense of today's. If you need a break, pause me before watching the lesson.
I hope you held on to your all-weather spacesuit from last episode, because the weather in this episode gets even weirder. Weirder than super powerful dust storms and acid rain? Yep. So say goodbye to Earth and the other rocky planets with solid surfaces. Today's all about the weather on gas giants. Before we take flight, though, let's get a little refresher on what weather is. We learned a few weeks ago that weather is the condition of the air or atmosphere on different parts of a planet. Even though there's only one atmosphere on Earth, the weather isn't the same everywhere, obviously. Things like temperature, humidity, and wind can change the atmosphere in a certain area, and together they determine what the weather is like there. But when you're talking about patterns of weather for a certain area over long periods of time, you're talking about that area's climate. And as we saw firsthand, Earth and the rocky planets all have both weather and climates. Who could forget about the extremely high and low temperatures on Mercury, and the heat and acid rain on Venus, and the crazy dust storms on Mars? I'm still sweating from our trip to Venus. Good thing the gas giants are a little cooler. But how else is the weather different on the planets farther from the sun? Let's take a virtual trip to Jupiter, Saturn, Uranus, and Neptune to see how extreme their weather is. First up, Jupiter. You might want to bring your storm gear for this planet, and, be prepared to keep it on for years. And years. And then a few more years. Jupiter is a big planet, and its weather is equally big. It doesn't just have storms. It has storms. That's because the planet is surrounded by jet streams, or fast-moving winds, some of which are flowing in different directions. When these opposing airflows meet, they create big, long-lasting swirling storms. Storms like the Giant Red Spot, a storm that's been brewing on the planet since possibly the 1600s. The 1600s! To make things even more interesting, the storm shrinks and grows in size and doesn't always stay in the same spot, although it always rotates in a counterclockwise direction below the planet's equator. And you thought storms on Earth could get wild. Let's take cover on our next planet, Saturn. Not that Saturn is less extreme. In fact, it's awfully windy here too. The winds on this planet can get up to 1,800 kilometers an hour. The strongest winds on Earth only get to about 400 kilometers an hour. These insanely fast Saturn winds, combined with heat from the planet's interior, are actually responsible for the yellow and gold bands we see in Saturn's surrounding atmosphere. So cold, but pretty. Next stop, Uranus. Much like its gas giant neighbors, it's cold. The temperatures on Uranus can dip as low as negative 220 degrees Celsius, and like Jupiter, it has pretty big storms, with winds almost as strong as those on Saturn. But it has one weird weather trait. Get this. Diamond rain. How does that happen? Well, the atmosphere on Uranus has a lot of gas called methane in it. Methane is a greenhouse gas that explodes when you light it. The methane on Uranus is put under lots and lots of pressure, which splits the gas into carbon and hydrogen. The carbon is then compressed under all that pressure into diamonds, which are pulled down or rained down into the planet's core. So, if you ever need to get rich quick, head down to Uranus and check out its diamond stash. If you have the time to do a little space travel. On to our final gas giant, Neptune. Oh, what a surprise. Neptune also has extremely high winds, powerful storms, and cold temperatures. I'm sensing a pattern here. But on Earth, the sunlight drives our weather. Neptune gets about 1,000 times less sunlight than we do. So how do we explain its wild weather? We don't. At least, not yet. Scientists aren't sure how this planet gets the energy for its intense storms and winds, which is fine by me. I love a good mystery, especially a good space mystery. So, if you're traveling to the gas giants, brace yourself for crazy storms and winds on Jupiter, Saturn, Uranus, and Neptune. And maybe bring a big bag to stuff all those diamonds in. But keep in mind, just like the rocky planets, the gas giants have weather sort of similar to what we have on Earth. Just, really amped up. I'm off to look for a warm, wind-free spot to spend my afternoon. And just in case, maybe I'll keep my eyes peeled for diamonds falling from the sky.
So there you go, grade sixes. That was a clip from Crash Course. I often say to my children in my class, if they didn't understand a concept, to just go and Google Crash Course. It's brilliant. It just sums it all up for you so beautifully. And for those of you that like to watch through video clips and things like that, brilliant learning tool. Okay, it gives you all the information you need for the curriculum. So, grade sixes, thank you for watching. I hope you have a really great afternoon, and I'll see you next time. Take care.